Welcome to Academy. This video is about filling up the standard trigonometry tables from first principles. I'm going to use two triangles in order to fill this up. I have an isosceles triangle and I have an equilateral triangle. What is an isosceles triangle? A triangle where two sides are equal in length. Let me name this triangle as A, B and C. And this is a right angle triangle. So this is the right angle which is 90 degrees, and from the basic properties of triangle, these two angles together should add up to 90 degrees because the whole triangle, all the three angles put together should be 180 degrees. So if this is 90, A plus C, that is angle A plus angle C should be 90 degrees. But since this is an isosceles triangle, these two angles must be equal and they should be 90 divided by 2, which is 45 degrees. Now, 45 degrees is pi by 4 radians. It's better to get used to using radians because as you progress, you will be increasingly using radians. So let us use radians as the angular measure. Okay, now let's go to this triangle. This is an equilateral triangle. Okay, this is an equilateral triangle. What is an equilateral triangle? Where all the three sides are of same length. And in an equilateral triangle, not only the sides, the angles are also equal. If I name this triangle as ABC like before, the angle A and angle B and angle C all are equal and they would be 180 divided by 3, 60 degrees. In other words, pi by 3 radians. Now, I have drawn a bisector from the vertex A. This line is the bisector of the angle at A. Since this is an equilateral triangle, this line is also bisector of the base BC. Therefore, if I name this as point D, BD and DC should be equal. Therefore, the angle at A is bisected into two equal halves. So, each one should be 30 degrees, or rather pi by 6. So I'm going to use these two triangles to fill this up. But what I'm going to do is I'm only going to fill up the sine and cos. The rest, tan, is nothing but the ratio of sine to cos, and secant, cosecant, cot or the reciprocals of cos, sine and tan respectively. So I'm just going to fill up the first two rows. The rest will follow automatically. First, let us look at the isosceles triangle. Let's take each of the sides AB and BC as one unit. AB is one unit, BC is one unit. Now I'm going to use the Pythagoras theorem to calculate the hypotenuse AC. AC is so AC square is AB square plus BC square, which is nothing but 1 square plus 1 square. Therefore, AC would be square root of 2, correct? So, AC is square root of 2. Let me mark it here. I'm going to use this triangle to calculate the value of sine pi by 4 and cos pi by 4, and as a corollary tan pi by 4. Let me rub this and continue further. Okay, let's look at cos 45. So if this angle is theta, cos 45 is, or rather cos pi by 4 is the adjacent side divided by the hypotenuse, which is nothing but 1 divided by square root of 2. BC divided by AC, which is 1 divided by square root of 2. So let me transplant this value to the cos pi by 4, 1 square root of 2. Now sin 45. If this is theta, sin pi by 4 would be opposite side by hypotenuse. Opposite side is AB. AB divided by AC. That is 1 divided by square root of 2. Did you notice cos pi by 4 and sin pi by 4 are equal, which is 1 over square root of 2. Therefore, what is tan pi by 4? It is the ratio of sin to cos. So that is 1, correct? Because 1 over square root of 2 divided by 1 over square root of 2 is 1. In fact, we can write the tan value from here also. If this is theta, tan pi by 4 would be opposite side by hypotenuse, which is AB by BC, which is nothing but 1 by 1, which is 1. So that's what we have got it here. Now, let's go to the equilateral triangle. I'm going to mark each of these sides as 2 units. If BC, the base, is 2 units, BD is 1 unit, because BD and DC are equal, therefore BD would be 2 divided by 2, which is 1 unit. Now, we know BD, we know BA. What is AD? And we have to use Pythagoras theorem to calculate AD. Let me write down here quickly. So AB square equals AD square plus BD square. AB square is 2 square. BD is 1. So we have to solve for AD. If you solve for AD, you will get AD square would be 2 square minus 1 square. Correct? Which is nothing but 4 minus 1, 3. That makes AD equals square root of 3. Let me mark here. So from this triangle, we can simply write down the values of sin pi by 3 and cos pi by 3, sin pi by 6 and cos pi by 6. Let's do it. We will not do the detailed calculation. Let's do it just by looking at this triangle. Sin pi by 3 is opposite side by hypotenuse, which is square root of 3 divided by 2. So sin pi by 3 would be square root of 3 by 2. Now, cos pi by 3 is adjacent side by hypotenuse. Adjacent side is BD, which is 1 divided by 2. Then sin pi by 6 is again opposite side by hypotenuse. That is BD by AB. That is 1 divided by 2. And cos pi by 6. Adjacent side by hypotenuse. That is square root of 3 divided by 2. See, I have pre-filled the values of cos 0, sin 0, cos pi by 2 and sin pi by 2. I have used the earlier video on unit circles and the animation video on unit circles. We have seen that when the theta is 0, sine value is 0 and cos value is 1. Similarly, when theta is pi by 2, the sine value is 1 and cos value is 0. So I just use that to pre-fill these four values. Now we can routinely fill up the other values, correct? Because tan is the reciprocal of sine to cos. Let me fill up. I'll explain one or two points here and there later. Okay, if you look at the table, I have left these spaces blank. I'll tell you why. First, let's look at tan pi by 2. Tan pi by 2 is sin pi by 2 divided by cos pi by 2. That is 1 divided by 0. 1 divided by 0 is infinity. But why it is infinity? Infinity is a very profound and intriguing concept. We will talk more about it later when I'm doing a video on the infinity as an exclusive video. But for now, you take it that anything divided by 0, any number divided by 0 is infinity. Now, let's come to secant. Secant pi by 2 is reciprocal of cos pi by 2. Again, cos pi by 2 is 0. Reciprocal of 0 is 1 by 0. So anything divided by 0 is infinity again. Next, cot pi by 2. Cot is the reciprocal of tan. Tan pi by 2 is infinity. So cot pi by 2 is reciprocal of infinity. The reciprocal of infinity is 0. Now, let's look at the cosecant 0. Cosecant is reciprocal of sine. That is reciprocal of 0, which is infinity. Cot. Cot 0, reciprocal of 0, again infinity. Okay, cot 0 is infinity because tan 0 is 0, the reciprocal of 0 is infinity. I know I'm not sounding very convincing because the concept of infinity is pretty profound and we will do a separate video later. But for now, let's take it that the reciprocal of 0 is infinity and vice versa. That is, the reciprocal of infinity is 0. Okay, let's proceed. I have filled up this table. Is it really necessary to remember this table, memorize this table? The answer is yes and no. Yes, because you need not do the calculations from first principles every time if you are very good in your memory. But for those who are not so good in memorizing things like me, I just can't memorize anything. If I memorize and go for an exam, I'll mess up. So you need to understand the fundamentals in calculation of this table. If you are not very good in memorizing, okay, and even if you are good in memorizing, there could be odd occasions where you have forgotten the values or not sure about the values. And if you know the fundamentals, you can quickly calculate yourself. Next, I want to tell you another cool method to remember this table or rather construct the table, but not from first principles, but sort of a jugaad. Here is a very interesting method to calculate this table using the fingers in your palm. The method goes like this. Each of your finger is assigned a specific place value for the 5 angles here. Thumb is 0, index finger pi by 6. The middle finger is pi by 4. The ring finger is pi by 3. And the little finger is pi by 2. Next, you close your fingers like this and count the number of fingers closed for cos theta. Cos, close, C, C. Count the number of fingers closed for cos theta and count the number of fingers open for sin theta. Remember, thumb doesn't participate in the count because thumb is just the place value holder for 0 and use a specific algorithm to calculate this table. Okay, I'll explain the algorithm now. Let's take the number of fingers counted as n. Step 1. Step 2. Take square root of n. Step 3. Divide square root of n by 2. Let's calculate. Cos 0. Count the number of fingers closed. 1, 2, 3, 4. So 4 fingers closed. Let us implement this algorithm. Cos 0, n equals 4. So square root of n is 2. And square root of n divided by 2. Is 1. So cos 0 should be 1 as per this algorithm, right? So 1 cos 0, it is 1. So this tallies. Next, cos 30. Place value for 30 is your index finger. So I have extended the index finger and now count the number of fingers closed. It is 1, 2, 3. Let us calculate cos pi by 6 using this algorithm. N equals 3. Square root of n is square root of 3. And square root of n by 2 is square root of 3 by 2. Does this tally? Square root of 3 by 2, square root of 3 by 2. Yes, the tally is done. Next is cos pi by 4. The place value holder finger is the middle finger. So I'm extending the middle finger also now. So the number of fingers closed is 1, 2. So 2 fingers closed. So let us do this algorithm. So n equals 2. Square root of n is square root of 2. Then square root of n by 2 is square root of 2 divided by 2. So cos pi by 4 should be square root of 2 divided by 2. It is 1 over square root of 2. Having one wrong? Not really, because 2 can be written as square root of 2 multiplied by square root of 2, correct? And 1 square root of 2 gets cancelled. So you have 1 over square root of 2. Here it is. It tallies. Then pi by 3. The place value holder is your ring finger. So I have extended the ring finger also. So how many fingers closed? Just 1. So let us calculate this algorithm. One square root of 1 and divide by 2. So cos pi by 3 should be 1 divided by 2. Here it is 1 divided by 2. Next is pi by 2. Now What is the place value holder for pi by 2? It is little finger. So I have extended the little finger also. So how many numbers, fingers closed? It is 0. So square root of 0 is 0. Then 0 divided by 2 is 0. So cos pi by 2 should be 0. Here it is 0. Now let's come to sine theta. In sine, remember, you have to count the number of fingers open. Okay, so let's start. Place value folder for 0 is thumb. So sine 0, number of fingers open is 0. So 0 square root is 0. So 0 divided by 2 is nothing but 0. So sine 0 is 0. Next, let us come to the place value holder for pi by 6 is your index finger. So extend the index finger and count the number of fingers open. It is 1, correct? So 1 square root of 1 square root of 1 by 2 is 1 by 2. 1 by 2. Next, pi by 4. The place value holder for pi by 4 is your middle finger. So extend the middle finger and count the number of fingers open. It is 1, 2. Remember, thumb doesn't participate. So there are 2 fingers open. So the algorithm will give you square root of 2 divided by 2, which is nothing but 1 over square root of 2. Similarly, your pi by 3. The place value holder is your ring finger. So extend the ring finger also. Count the number of fingers open. 3 square root of 3 square root of 3 divided by 2. So sine pi by 3 should be square root of 3 divided by 2. Now let's come to pi by 2. Sine pi by 2. What is the place value holder for pi by 2? It is your little finger. So extend the little finger also. So the number of fingers, remember thumb doesn't participate. Number of fingers open is 4, correct? So 4 square root of 4 is 2. 2 divided by 2 is 1. So sine pi by 2 should be 1, correct? We are done. The rest of the ratios follow from sine and cos. So this is a very cool method, which is, I would say, it's just a shortcut. I would say it's a stupid shortcut, because unless you remember the fundamentals, you will not reach anywhere. Because shortcuts generally do not lead to destination, but they could be useful under certain situations. Thanks for watching. My next video will be the calculation of trigonometric identities for complementary angles, that is cos pi by 2 minus theta and sin pi by 2 minus theta, and that would be the stepping stone for the detailed calculation of all the trigonometric identities from first principles. As always, it will be an immense pleasure to have you back with Academy. Thank you.